In just a moment, we're going to take a look at what's new in Fermi Spin 0.8. From TLS for DB connections to JavaScript routing and OCI Registry Support. Let's dive in. So the first thing we're going to take a look at is the new JavaScript router. What does this mean? Well, typically, architecting your Spin applications, you add a single component for every path in your application. However, sometimes, depending on the complexity of your applications, you may want a single component that handles one or more paths, probably even a collection of subpaths. And to do that, the Spin Node.js SDK provides you with the Itty router. Let's take a look. So the JS routing project here was generated using Spin New and selecting HTTP TS for a TypeScript example. I've literally copy and pasted all of this code from the release blog, which is available in the description and on the screen now. As you can see, we have the ability to request a new router from the utils package. Now at first you might be wondering, hey, where is utils coming from? It's not imported. Well, don't worry about it. This is provided as a global in the TypeScript definition file. So you can call it with ease. From here, we can add, using the HTTP method that we want to capture, new routes. Here we're adding a get route of slash, and here a get route of slash goodbye. You can use any HTTP verb, such as delete, patch, post, put, etc. From in there, you're just writing any standard Spin endpoint. As you can see, we can just return a 200 and use the encoder to drop goodbye into the buffer. Whereas here, we just say, hello, Spin is handling this route. To connect the dots, we export a handle request function, which just returns router handle request. Nice and simple. This gives you a bit more flexibility into how you architect and compose your Spin components into Spin applications. Next up, TLS support for outbound database connections. Previously, you couldn't talk to any cloud-style database that exposed their API over TLS. It's a free Postgres service built in a serverless fashion that's very easy with a very low friction onboarding experience. But I couldn't use it because I needed TLS. PlanetScale also offer free databases. CockroachDB also offer free databases. We're in a wonderful world where if you want to store data for free online and not have to worry about backups, policy, RBAC, etc., it's there. However, it was a challenge to use in Spin. Now, that's not a problem. Using the Rust SDK for Spin, I'm able to define a show. I create a try from function to allow me to coerce a row result from the Postgres driver into a show struct. We can add a format column function to make it easier to print the data to the terminal. And then we use the Postgres module just like we could before. In fact, nothing in this code is any different from pre 0.8. So let's see it working. In my spin.toml, I have a Neon Tech, an online free Postgres database available with my username database, and I'm hiding my password for now. I can jump over to the terminal and run spin up. Now we have an endpoint that's going to read all of the shows from my Postgres database. And we can run localhost 3000 like so. This speaks to Neon Tech, the remote TLS server-based database, and spits out my shows to the terminal. Such a small change, but with powerful possibilities. Lastly, and probably my favorite feature in 0.8 is support for OCI registries. This is going to make interop and hybrid applications with WebAssembly and containers a whole lot simpler because they use the same discoverability and distribution mechanism as container-based applications. Here we have a Spin application using the Spin file server, which delivers static assets like my very simple index.html. I provided a just file here, one with an image name, and here I'm using the GitHub container registry on my own repository to store the Exploring Spin What's New 0.8 application. We can do a push using Spin OCI push with the image name. Even cooler than that, we can sign this because it's a standard OCI artifact. We can use cosign. Ain't that sweet? Lastly, for the demo, I'm going to do a push and sign. So let's run just demo, like so. Spin OCI push is now building the WebAssembly artifact into an OCI artifact and pushing it to GitHub's container registry. Next, cosign is going to sign our image for us, and we can just confirm the prompt. This will ask me to log in with my GitHub credentials, like so. Now, let's clear the screen and run just verify. This runs a cosign verify against the image that we just signed. We can see the claims were validated, the existence of the claims were verified in the transparency log, and certificates were verified against the Visio root. And we can see this was signed with my GitHub credentials. Awesome. And that is Spin 0.8. The Fermion team continue to impress me with their velocity, cool features, and shiny new things to play with. So, we'll see you for the next video in the complete guide to Spin. Until next time, have a great day.